Now let's consider how to analyze categorical data. So we're looking at descriptive statistics, and the idea is we want to analyze. We just want to kind of describe what's going on, and we have a categorical variable. Well, a common approach is to create frequency and relative frequency tables of a categorical variable. These are just fancy terms for relatively straightforward analyses. So frequency table, in statistics, frequency just means count. It's just a fancy word for count. So frequency table is just a table of counts for each category. A relative frequency is just going to give you the proportions or percentages for each category. It's going to tell you how many people, so frequency table will tell you how many people are men and how many people are women. Relative frequency table would tell you what's the proportion of men and what's the proportion of female, or equivalently, what's the percentage of men and women in a particular data set. We can also graph a categorical variable, and we have lots of options, but by far the most common approach is to create a bar graph in which the bars just indicate the counts of observations, and the areas, the heights of these bars, they represent that frequency for each category of a categorical variable. An alternative is a pie chart, which you might see instead of bars, you have wedges of a circle, and the idea is that areas of these wedges, they correspond to the proportions for each category. In most cases, statisticians prefer bar graphs over pie graphs because pie graphs can really be misleading, and they can hide or mask differences among different percentages or proportions in the data. Another consideration is when you visualize data is how do you create a good statistical graphic? Right? This is subjective, right? But one point is that these are basic principles that have kind of come into play, especially recently. A big field of data visualization has come into play and has become quite popular. And this is really the merging of statistics with graphic design. The idea is that we don't want to mislead people using graphical displays. And how can we mislead people? Well, we can have biased labeling, so you can kind of prompt or prime people who are looking at a graph in a certain way based on the labels you use. You can have misleading scales that differ for one variable than another. You can have no scale, so make sure that your labels and axes are clearly defined and labeled. Another issue is about excessive visualization. The idea is when you have excessive visualization, you have a low data to ink ratio. Right? You spill a lot of ink to say very little about the data. Another issue is a violation of the area principle if different parts of the graph have unequal areas. Basic idea, this goes back to Edward Tufte, a statistician at Princeton, but the idea is you want to avoid a low data to ink ratio. Well, what does that mean? Well, here's a relatively lower data to ink ratio, here's a higher data to ink ratio. The same graph, but one has more visualization than the other. And these excessive visualizations might be misleading. People might be, their eyes might go towards the red bar might look larger. So as a general rule, statisticians prefer more minimalist statistical graphics. Of course, you can create whatever graphics you want. In some cases, people will want a pie chart or they'll want certain visualizations, and that's okay. But according to statistical graphics, one principle is really avoid a low data to ink ratio. As well with categorical data, besides visualizing categorical data with bar graphs and analyzing with frequency tables or relative frequency tables, when you have two categorical variables, you can create something called a contingency table, sometimes known as a cross tabulation. It's just a table of counts, proportions, or percentages from two categorical variables. The reason it's called a contingency table because it can tell us how these observations or cases, how they're distributed along each variable contingent or conditional on one or more categories of the other variable. So you can really work a lot with a contingency table. As well, you can visualize contingency tables using what's called a Mosaic plot. Mosaic plot really consists of two steps. First, you take a square and you divide it into two vertical bars. And the widths of these vertical bars are proportional to the unconditional distribution of a categorical variable. This is assuming you have two levels of a variable, by the way. But the idea is that if you have more than two levels, if you have 5 levels, then you're going to divide that block into 5 different vertical bars. And the width of each bar is going to be proportional to that unconditional distribution of some categorical variable. Then what you do, after you have these vertical bars, you split each bar horizontally, each vertical bar horizontally, proportional to the conditional distributions, right, within each of those levels. Right? So we can look at this. So we take a square and we divide it into two vertical bars. These widths of these bars are proportional to the unconditional distribution of the first categorical variable. So this first categorical variable is a percentage or proportion of men and women, the proportion or percentage of people who survived the Titanic. So we have 41% did survive, 59% didn't survive according to this data set. So you can see that one bar is a little bit larger than the other one. Okay? Then what we can do is we can split each bar horizontally proportional to the conditional distributions of the row categorical variable. So this will tell us the distributions of class conditional on survival. And this way we can express some of the, the conditional distributions of a contingency table using a Mosaic plot. And with that, we conclude this part in which we talk about categorical data analysis in the context of descriptive statistics.